Hi everyone, Dr. Frank LaPanca. This video will focus on data types and visually representing data. This will be the theoretical basis for visualizing data. Two additional videos, one on creating a table in proper APA format and one on creating visual representations of data will be in addition to this one. Why don't we go ahead and take a look at some data. So one of the most straightforward and visually easy ways to represent data is through what's called a stem and leaf display. Basically, what you do is you divvy up a set of data based on their place value. So in the example shown here in the table presented, we've got a series of numbers, and those numbers 10, 9, really represent 100, 92, 93, 96, 80, 81, 82. So let me show you actually how you would create a stem and leaf plot very simply from a set of data. I'm going to use for an example a set of test scores. Okay, so I've got a set of data we're going to take a look at. And these are, what I'm saying, are a set of test scores to make the stem and leaf plot. And so I'm going to do a scan of what I've got. My lowest score is a 40. I've got some 60s, 70s, 80s, 90s. So let's do this. We have 90 as the highest. So we do 9, 8, 7, 6, 5, 4, because I know that's the lowest score we have. I think that'll be enough. And we draw a line like this. These are the stems. Now we're going to add the leaves, or the leaves. So let's see what we got for 90. Now, some of it takes some organization. If you're doing this in a spreadsheet, you can certainly sort the spreadsheet when you start. Or what I'm going to do is I'm just going to try to do it from my. So I've got 40s. So I got 42. So I put the 2 there. Now let's go. We don't have any 50s. We have 160. It's a 68. So I put the 8 there. Now we've got 70s, and we've got 76 and 78. Okay. So then we do the 6 and the 8. And we do that in numerical order. Make sure we do that in numerical order. Then we look at the 8s. We got 84, 85, 87, 87, and 88. So we have two 87s. Let's not miss that. So we'll do 84, 85, 87, 87. Notice I put the number 2 down twice. And 88. And then we have 90. Did I forget the 79? I missed the 79 there. Luckily, it's in the right order. 79 there. And we got 91, 93, and 98. And now we've created our stem and leaf plot. If we look at the stem and leaf plot, what we can see is kind of patterns. That's really what we're looking for, is like what kind of trends can we just visually observe? It looks like there is more over here, a little less, goes up, goes down, and then there's some downward stuff. So the majority of my students are in the 80s, a few in the 70s, a few in the 90s, and then we have 2 lower scores. So that describes for us what a stem and leaf would look like. Here's another simple way to represent some qualitative data. These are frequencies. Frequencies are the number of times something appears. Sometimes frequency is referred to as the letter N. So N is also frequency. And so in this table, the way it's set up, you can see that there are entry positions listed here for someone to become a chief academic officer. That's the idea here. And so do they get from faculty or where do they come from to get it? And so the frequency is just the N, or the number of times that event happens, and then the percentage turns that into a relative number. Simple table. One thing I do want to note, because this is a table construction, uh, text is always justified to the left, but numbers are always justified to the right. Specifically, decimal points must align. So you can see here the way the decimal point aligns, and then because there's no decimal numbers or values here, you can see that this is just at the units place or the ones place. I would say this would not be compliant with normal stats expectations because if you notice, the this goes to the 10th place, 1 decimal place, but we know that in stats we either go to the 2 decimal places or 4 decimal places. So 0, 2, or 4, that would be the proper way to format a table. Frequency, as I said, is basically part divided by whole. We got kind of get that sense with probability too, the part versus the whole. That's the way you get the percentage or frequency. Now let's talk for a few minutes about discrete versus continuous data. And this is really important to understand the difference between discrete and continuous. Discrete is each data point stands on its own. In other words, a data point here is not directly related to a data point here. There's not a continuity. Discrete data is typically in the graphical form represented in bar graph form. Continuous data, the points relate to one another in some way, say something over time, for example. It's continuous because the points are specifically related to each other. Let's look at some examples. I think that's the best way to consider the difference between discrete and continuous. So here's a bar graph. It's percentage of states addressing key issues. And and you can see here, these are represented in bar, any proxy, personal instructions, general life sustaining, uh, those are being addressed. But it's discrete because personal instructions don't have anything to do directly or continuously to general life sustaining or terminal illness, artificial sustenance. Uh, these items are not directly related, so we draw them as bars because one plot it doesn't matter that this is 100 to this being 98. They're independent sets of information. This is a pie graph. Pie graphs are not used that often, very honestly, but we always talk about them. Pie graphs represent a whole and parts of the whole. So respondent's primary line of business is what's being represented here. Um, and you can see the way the pie is. There's a whole set of individuals, the whole part, and then each wedge represents what proportion. This could also very easily, because it be represented as a bar graph as well. So this would maybe work as a pie graph, maybe work as a bar graph, up to the researcher's decision-making process in this. Um, this is a subjective view of sports forced into unfamiliar settings. So this is just kind of a little creative thing here, where we have the sports on the left, the unfamiliar locations on the right. If you notice, these are being plotted in quadrants. These are relationships of individual points. The x-axis and the y-axis are directly related to one another. So we come and we cross and we find points. This is actually categorical data too. So this is not continuous data. Notice no points are connected. This is still discrete data. Now let's talk for a little bit about the different kinds of data types you might experience. They are nominal, ordinal, interval, and ratio level data. It's important when making decisions on what kind of analyses you want to do to best understand the data types. Uh, the noir is just kind of the way you can remember the order of them, a little mnemonic device. So nominal data is categorical data. Basically, I like to think about categorical data as buckets. Things go in buckets. They're typically frequencies. So what's your favorite color? The blue bucket, the red bucket, the green bucket, the yellow bucket, and so on. And how many individuals? They're nominal. It's just categories make up the data. Ordinal data is rank data. And basically, rank data, when you consider rank data, the distance between 2 points may not be the same. I'll give you an example on paper. So let's take a look at this data, set of data that we're going to consider ordinal or rank data. So let's say this is representing averages in a course. And let's say there's 20 students, and then we're going to mark the students along this where their averages are. So let's say there's 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 students. Okay. So now I want to rank these students. I want to have the top 20%, the middle 20, and so on. So let's say top 20% is 5, right? So right here are the top 5. And the next 5 are here. And the next 5, 1, 2, 3, 4, 5, are here. And then the bottom 5 are here. So we're going to say this is our number 1 group, our number 2 group, our number 3 group, and our number 4 group. Those are our rank groups. We can see in this example that 1 is a much tighter band than say 4 is. It spans over much more time. But there's still a number of individuals in there. So this rank is the distance in ranks is different. So even though this is rank 1, this is 2, 3, and 4, they're not equidistant apart. The bottom level is equidistant apart, and this is interval level data. So we have ordinal and then interval. Interval level data means there is an equidistance between points. This is how you would typically represent numbers. On a number line, the space between them is all the same. The only difference between interval ratio and interval data and ratio data is that ratio data has an absolute 0 at some point. So there is a 0 point. Interval level data may not have a 0 associated with it. I'm going to end this section by taking a look at this graph because I think it's a wonderful representation of data because a lot of stuff is happening here. This is a very old French figure that is represented. So there's interval and nominal and ordinal data things happening here. And let's just take a look at it and take a few moments to analyze it. What I'm going to suggest you do is just hit pause for a second, take a really good look at it, and then resume the video. This graph tells the story of Napoleon's march to Russia. And what it does is it represents people, it represents a lot of things. First of all, it represents the distance traveled. So we've got the distance traveled and locations on it. And then we have this bar here representing the number of individuals that start off and then continue along the journey. You can see the troops get smaller and smaller and smaller till they get there. I think it was a really bad Russian winter when this was created or when this event took place, and then they march back, and you see the population is getting smaller and smaller and smaller. Oh, look, this is kind of interesting too, right? Like a group branches off here, comes this far, and then turns around and comes back. So you can see here this population merging with this population, more people, but then they continue to die off. So we started with this many people visually. And then the population, which is 422,000, I think is what I'm seeing on the graph. And then it's down to like 10,000 on the way back. So significant decrease in individuals. We also have temperatures and what happens temperature-wise along this journey and different places. Just a wonderful representation of what data might look like. So part 2 is let's look at how to create a table, an APA compliant table in Word, and then visually representing data, which will give you an experience of taking data sets and analyzing it and creating graphs out of it. But when you're complete with the class practice stuff, then there is an assignment for you to do so you can demonstrate the skills on your own. So the video will take you through step by step of the process. You can pause and stop along the way. Then you take an assignment and use the data set there to do the work on your own. All right, thanks very much, and see you in the table creation video next.